Hi, I'm Rex Black, President of RBCS. Welcome to the RBCS YouTube channel. Hey, I hope you enjoy all these free resources that are available here. And do us one favor. We need to keep the lights on and we need your help to do that. So, when you need testing and quality related services, training, consulting, expert services, you name it, let us be one of the bidders on that next job. We don't expect to get all of your business, but we'd like to get a chance. Thanks and enjoy the shows. On behalf of RBCS, welcome to today's webinar on One Key Idea. I'm Rex Black, President of RBCS. We're a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world, and we have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. I am the author of 12 books on software testing, including the bestseller Managing the Testing Process, and actually now 5 books on the ISTQB program. So today is a continuation of our One Key Idea series of webinars. So this is a brief but hopefully very interesting and applicable topic. So in the next 15 to 20 minutes, I want to give you insights into the creation and use of decision tables from a testing point of view. So let's get started on that. So we'll start off by looking at an example of a decision table. Excuse a drink of water there. This is a decision table that shows the logic used to decide how to handle credit card processing. So this is something that might be part of a back-end web services credit card processing system where it gets information from an e-commerce application of some kind or another, or other site that allows people to make purchases, and from there it evaluates the data that it's received and decides whether to approve the transaction, whether to inform the call center to call the cardholder, or whether to inform the call center to call the vendor. So this has the form of a typical decision table. We have the conditions shown on the upper right side of the table, or excuse me, upper left side of the table, and the actions to be taken or not taken are shown at the bottom left side of the table. So you see there's 4 conditions there, whether it's a real account, an active account, it's within limit, or the location is okay. All of these conditions are what are called Boolean conditions, meaning that the value is true or false, yes or no. We have 3 actions: whether the transaction should be approved, whether we should call the cardholder, and whether we should call the vendor. And then the top half of the table, or top portion of the table, contains every possible combination of conditions. So we have 4 conditions, each of which has 2 possible values. So 2 times 2 times 2 times 2, 2 to the 4th power, 16. There's 16 columns in the table. And you see they have a nice predictable pattern to them. The top condition, there are 8 yeses and 8 nos, and then the condition below that, active account, 4 yeses, 4 nos, 4 yeses, 4 nos, so forth. And then for within limit is 2 yeses, 2 nos, 2 yeses, 2 nos. And then for location okay at the bottom, it's yes, no, yes, no, yes, no. So that nice predictable pattern is valuable if you're going to construct a full decision table, to use that predictable pattern on the top, so that you don't get lost and ask yourself, hey, have I covered every possible combination? And then the actions to be taken, of course, are determined by the specific combinations of conditions which are true and which are false. So these are a function of the business logic. And this is what makes decision tables a nice compact way of describing business logic, because here on this table, we are able to express the 16 theoretically possible situations that could arise, and how those should be handled. And this is something that would be very verbose and easy to screw up if expressed in words, in free-form text. Now, another thing that's nice about these, not only are they a compact way of representing the business logic of the application, they're also a very nice way of deriving tests, because what we can do is say that we've covered the table if we create and execute a test, at least one test, for every column. So we want to create a situation where we've got tests for column 1, and we check that the actions taken and not taken are correct, and then we check column 2, are the actions taken and not taken correct, and so forth. So very nice compact representation of the business logic of the application, and a very nice portable and simple way of testing it. Now, these are called full decision tables because they have all the possible combinations of values in them, conditions that is. So what we can see is that there are those 16 possible combinations. Sometimes if you look at some of those combinations of conditions, you might say, you know, those don't really make a whole lot of sense. Like if you look at column 11, you say, okay, well, it's a real account. This is an actual account for an actual customer. That's the real account, yes, no. So for column 11, the answer is no, it's not a real account, but it is active, right? So the active account is yes in column 11. Well, that just doesn't make a lot of sense. And what you find is if you look at columns 9 through 16, there's actually a number of somewhat nonsensical combinations there of, it's not a real account, but it's within limit, or the location is okay, or it's active, or one or two or more of those. So it doesn't necessarily make a whole lot of sense. So what we can do to accommodate that is through what's called a collapsed decision table, which is what you see here. So in a collapsed decision table, you take a full decision table, and what you do is you combine the rules, the columns, that are characterized by differences in conditions that don't actually matter. So for example, column 9, it represents columns 9 through 16 in the full decision table. And it basically says that if it's not a real account, so if real account is no, then none of the other conditions matter. That's what those dashes mean. They mean this is just not important conditions. And we can ignore them. And the correct actions to take are: we should approve, we should not approve, we should not call the cardholder, but we should call the vendor. So similarly, we can collapse rule 4 and 3 together, saying that if it's a real account, an active account, and it's within limit, the location doesn't matter. We're going to disapprove the purchase, call the cardholder, and not call the vendor. And then similarly, rules 7 and 8 collapse down into the new rule 7 in the collapsed table. If it's a real account, it's not active, and it's not within limit, then we're going to ignore the location, and we're going to not approve it, call the cardholder, and call the vendor. And notice that I've retained the numbers, the column numbers from the original table there, so you can, if you want to print out the PDF here and take a look at them, you can compare side by side and go, oh yeah, look, so I see which columns collapsed into which other ones. Now, something to note, of course, is that the formula that applied for the number of columns in the full decision table, which was 2 to the number of conditions power, 2 to the 4th, or 16, doesn't apply when you collapse them, because they're collapsed based on the actions, which are, of course, business logic. And so the business logic is determined by human decisions, and therefore a mathematical pattern like what you saw in the full decision table doesn't apply. The rule for testing this is again the same, that what you would do is run at least one test per column. So you create the appropriate inputs and verify that the appropriate actions are taken and not taken. Now, when to use one versus the other? Well, if the risk is relatively high and you want to try to force doing things, force making things happen that are maybe very unlikely or maybe even theoretically impossible, but nonetheless are something that you think you want to try to force because of the risk, then you would want to use a full decision table. In a less risky situation where you think, okay, we can afford to ignore things that are just impossible or not going to happen, very unlikely to happen, then you use the collapsed decision table. So these are a very nice, compact way of representing tests and representing business logic. If you find this to be interesting and you're thinking, there's a lot of different ways I could apply this, we have a recorded webinar that part of the Advanced Software Testing series that is out on the YouTube channel that you can give a listen to, and that will give you a much more extensive description of the ins and outs of decision tables and some of their complexities and so forth. But in this one key idea series, the objective is to introduce you to an idea which you may or may not find useful, and if you do find it useful, hopefully it's inspiring you to go off and look further. So let me open it up for questions here. Before we do that, just a quick word on if this wants to cooperate, which it does not. It does not seem to be wanting to cooperate. Sorry, one moment, please. Demo effect. Okay, well, I'm going to open it up for questions. So if anybody has questions about use of decision tables, and I see we have a question from Donald Farr here, long-time listener there. Hi, Donald, good to hear from you. He asks, are there any decision table tools that you would recommend? I can't say that I am aware of any, Donald. I don't think it would be terribly hard to construct a tool. There may be some open source ones out there if anybody wants to throw a name out, but I haven't come across any that are in use. I think in part because once you've mastered the creation of these things, it's really simple enough to build them. And once you've built a few of them, you're going to have a number of templates laying around that you can reuse pretty easily. Other questions? Let's see. Fadi has a good question here. The number of columns or rules grows exponentially with an increased number of conditions. When does this technique become impractical? Excellent question. Yes, for a full decision table, the number of columns will indeed double each time you add a new Boolean condition, and it could be even worse than that in that you can have conditions that are non-Boolean that might have 3 or 4 or more possible outcomes. So the number of columns can increase quite significantly. The thing to keep in mind about this is that what you're trying to deal with when you're dealing with decision tables is are conditions that actually interact. So you want to try to avoid putting conditions into the table that don't interact with other conditions in the table. In other words, are fully independent. Because while there are ways of doing that through what are called non-exclusive rules, if you try to do it in the full decision table approach where you capture all possible combinations, you're basically modeling interactions that aren't supposed to occur. So either leave the conditions out that don't interact, can't interact with the other conditions, and deal with testing those using separate techniques, or if you are going to put them into the table, you use what are called non-exclusive rules. And I believe the recorded webinar that's on the YouTube channel will tell you how you can test when there are non-exclusive rules. Fadi says, interesting points. Thanks. Okay, any other questions on this? Again, the one key idea, webinars, in contrast to our sort of full-blown 90-minute webinars, are meant to be a real quick hit, give you an idea, and have you go away and think about it. So hopefully it's given you some food for thought here. We seem to be out of questions, so I'll go ahead and close the session down. Keep in mind, we do run these free webinars once a month. The key idea webinars are every other month, and the full ones are every other month. So this is June was a key idea month. They are run in the afternoons only. There's no evening session. You can go out to our website, rbcs-us.com, and sign up for upcoming webinars. You can also sign up for our free newsletter there. And that comes out on a regular basis every other month. And one just came out, or actually it's just coming out tomorrow. So if you sign up, you'll be in perfect time to catch it. You can see some contact information for me here. There's Twitter and LinkedIn and YouTube. The recorded webinars are posted out on the YouTube channel within like 2 or 3 days after each webinar, as well as there being a whole bunch of other resources out there on the YouTube channel. So enjoy. And then, yeah, you can follow me on Twitter. I'm pretty active on that, on social media. Let's see, I got a couple last minute things coming in here. Alex has contributed something, which is a tool, looks like a decision table tool from SourceForge. And what I'm going to do is I am going to forward this link to everybody. At least I think I am. Either that or I'm going to get tripped up by the UI, and I'm going to delete. Yeah, okay. There we go. Yep, so it looks like got that out there. I had a question from Donna about orthogonal arrays. That was closed. That's been addressed on. There are 3 pairwise testing links that have been posted recently on my blog, rbcs-us.com/blog. Go take a look at those, Donna. Miguel's got a question here. What is the name of the full webinar related to decision tables and how to optimize testing for them? It's called Advanced Software Testing using decision tables or something like that. So it's out on the YouTube channel. Miguel, go give it a listen out there. Again, this purpose of this webinar is to be quick intro, give you some thoughts. If you think, hey, I've got interacting conditions with my testing and I need to test them. So, all right, great. So one last point to make, please keep in mind that we offer all these free resources, our YouTube channel, our blog, our articles, our free newsletter, et cetera, as a resource to the software testing community. It's a service that we offer. We are a not just for profit company, but we do need to keep the lights on, so we would appreciate it when your needs arise and you need help with expert services, training, or consulting related to software testing, quality, defect management and incident management, et cetera. Let us be one of the bidders on your project. We don't expect to win all your business, but we'd certainly like to get a chance to bid on it. So I thank you all for your attention today, and would encourage you, if you found this to be a appetite whetting experience and you want to go and learn more about decision tables, take a listen to the Advanced Software Testing Decision Tables webinar out on the YouTube channel. It's yet another free resource. Thanks, and see you next month.